So let's start with section 3.3. The first thing we're going to learn is the long division, or it's called the division algorithm. So if we have f of x and d of x are polynomial such that d of x not equal to the 0. Like here's f of x, so just keep in your mind, here is f of x divided by d of x. F of x divided by d of x. Of course, d of x is supposed to be not equal 0, because anything divided by 0 is going to be undefined. And the degree of d of x is less than or equal to the degree of f of x. D of x less than the degree of d of x. That means the power of the highest exponents here is less than to the power of the highest exponents of f of x less than or equal. Then there exists a unique polynomial q of x, which is, let's say, this is the solution of the division algorithm, and r of x is the remainder, such that the division of f of x divided by d of x equal q of x is called the quotient, which is the solution of the division algorithm, plus r of x, the remainder, over d of x, which is the divisor. This is called the division algorithm, or the long division. The same thing can be written as, now here's this one is the solution of the f of x divided by d of x is going to be q of x plus r of x over d of x. If you multiply everything here by r of x or by d of x, so f of x, you're going to multiply by d of x. Let's do it on the side, just so you can see what we're doing. If here's the polynomial I have, f of x divided by d of x equal q of x plus r of x divided by d of x. If I multiply everything by d of x, that means it's going to be f of x over d of x times d of x equal q of x times d of x plus r of x divided by d of x times d of x. This one cancel with this one, so the left is just the polynomial of x equal q of x d of x plus cancel d of x r of x. That's what we got on the next step. So if you multiply f of x over d of x both sides by d of x, this is what we're gonna get. Now, two notes we have. We're gonna take some examples about how to use the long division. I need to write down this. So how we're gonna get from here to here, which is the same thing. Next, the next two notes is if f of x, this is the first note, if f of x over d of x, that means this part is called improper because the degree of f of x is greater than the degree of g of x. So they're gonna ask you, is this a improper fraction or division? Yes, because if the degree of f of x is greater than the degree of d of x. If the opposite thing, called a proper fraction or division, because the degree of r of x, the degree of r of x less than the degree of d of x, r of x less than the degree of d of x. So every time when you see fraction, or we're talking about polynomial, if r of x and d of x is called proper because the degree of r of x less than the degree of d of x. So they're gonna ask you the first 5 or 6 examples only about these two notes. The next part, we're just going to take example how to use the long division. So to use the division algorithm, the first thing, write the dividend and the divisor in descending order. That's really important thing. Before you start using the division algorithm, you're gonna write down the dividend and the divisor from the highest exponent to the lowest exponent. The second thing, intersect the placeholder with the 0. That means if you see any of these exponents are missing, like x squared, if missing, you're going to put instead of x squared, 0x squared. This is also really important, coefficients for the missing powers of the variable. So I'm going to start doing an examples, because by doing examples, everything is going to be easy before I move into the next method, which is the synthetic division. So let's start with doing example 7. Example 7 says, use the long division to verify that y1, which is this side, equal y2, which is this side. Okay, so y1, this is example 7. We have y1 equal x squared over x plus 7. So I'm going to keep in my mind, this is f of x, and this one is d of x. And that's what we're doing, f of x divided by d of x. Now I'm going to look to f of x. I'm going to use the division, but before that, the missing here is the x and the constant. So I'm going to say y1 is equal x squared plus 0x plus the constant 0. And everything is divided by x plus 7. There is no missing here because here's the highest exponent and the constant. So every time when you see missing variable, just put 0 with the variable plus 0. Now we're going to use the long division on this side. So I'm going to say, here is x plus 7, the divisor, and here is x squared plus 0x plus 0. Now I'm going to start dividing. X squared divided by x. You see, always I'm start dividing these two variables. So x squared divided by x, that means you can do it on the side. You can say x squared divided by x. X squared divided by x is going to be x. That means here is an x. Then I'm going to start multiply. X times x is x squared. X times 7 is going to be plus 7x. The next step, I'm going to change the sign. This is plus, minus, plus, minus. X squared minus x squared is going to be 0. 0x minus 7 is going to be negative or minus 7x. I'm going to write down the 0. The next step, I'm going to keep going the same thing. Negative 7x divided by x, always dividing the first variable here. Negative 7x divided by x is going to be negative 7. So here is negative 7. Now multiply. Negative 7. I'm not going to multiply the whole thing, just this one, the one I added here to the quotient. Negative 7 times x is going to be negative 7x. Negative 7 times 7 is going to be minus 49. Then what I'm going to do, I'm going to change the sign. This is minus is going to be plus, and this is minus is going to be plus. So now this is 0. 0 plus 49 is going to be 49. Now this is q of x. This is r of x, the remainder. See, now the remainder is not equal to the 0. This is d of x. and this one f of x. That means to write down the solution, we're going to say f of x divided by d of x equal q of x plus the remainder divided by the divisor. And this one equal q of x, which is x minus 7, plus the remainder, which is 49, over the divisor, which is x plus 7. If you look to this one, it's exactly like y2. If you look to the y2, it's x minus 7 plus 49 divided by the divisor, which is x plus 7. So that's it for this example. I'm going to say yes, y1 equal to y2. So here's example 8, x cubed minus 2x squared, x cubed minus 2x squared plus 3x minus 1 and divide by x plus 2. The first thing, this is f of x, and this is d of x, the divisor. This is the polynomial, this is the divisor. Now we need to check the f of x. There is no missing variable, cube, square, 1, and the constant. So I'm going to start dividing right away. Here's the divisor, and here is the dividend, minus 2x squared plus a 3x minus 1. So now let's check. First of all, we're going to start dividing this number. X cubed divided by x, so it's going to be x squared. Then I'm going to multiply. X squared times x is going to be x cubed. X squared times 2 is going to be plus 2x squared. Then I'm going to keep going. Change the sign. This is a plus, is going to be minus. This is a plus, is going to be minus. Then this one is going to cancel. Because 0, x cubed minus x cubed is 0. Negative 2x squared minus 2x squared is going to be negative 4x squared. I'm done from the first step. I'm going to write down now this term, which is a plus 3x. Then I'm going to start the second step. Do exactly the same one. Negative 4x squared divided by x. You can do it on the side. You can say negative 4x squared divided by x. So it's going to be negative, cancel this one with this one, negative 4x. So negative 4x. Now negative 4x times x is going to be negative 4x squared. Negative 4x times 2, negative 8x. Now change the sign, plus, plus, negative 4 plus 4 is going to be 0. That means this is cancel. Now 3 plus 8 is going to be 11. So it's going to be 11x. Now let's keep going. We're going to write down the last term, which is minus 1. Last term is minus 1. Now we're going to say 11x divided by x. So it's going to be 11. We're going to do a multiplication. 11 times x is 11x. 11 times 2 is going to be plus 22. Change the sign. This is a plus, it's going to be minus. This is plus is going to be minus. This is going to be 0. -1 minus 22 is going to be -23. That's it. We can't move on because this is going to be the remainder R of x. And here is the quotient. This is Q of x. That's mean f of x divided by d of x is going to be equal Q of x plus R of x divided by d of x. And this one is going to be equal Q of x, which is the quotient, x squared minus 4x plus 11 plus the remainder is 23. So -23 over the divisor is x plus 2. Now I have two signs here. I'm just going to simplify it. So this one is going to be equal x squared minus 4x plus 11 minus 23 over x plus 2, which is this one exactly what we have here, x squared minus 4x plus 11 minus 23 over x plus 2. So we're going to say yes, y1 equal y2. Here we go. Any questions so far? On example 9, they ask you use the long division to divide x to the power 4 plus 13x cubed plus 40x squared minus x minus 8 divided by x plus 8. The first thing, again, the first thing always, we need to check the exponent. So example 9, if we check x to the power 4 plus 13x cubed plus 40x squared minus x minus 8. Everything is divided by x plus 8. So first of all, I'm going to check here x 4, 3, 2, 1, 0. So that means this is okay. There is no missing term. The same thing here. There is no missing term. So I'm going to start the long division. I'm going to say here is x plus 8. And on this side is going to be x to the power 4 plus 13x plus 40x squared minus x minus 8. So let's start dividing. The first number, x to the power 4, divide by x. Let's do this on the side. X to the power 4, divide by x is going to be x cubed. So I'm going to write down x cubed here. Then x cubed times x is going to be x to the power 4. X cubed times 8 is going to be plus 8. This is a cubed here. It's going to be 8x cubed. Then I'm done from the first step. I'm going to say this is a plus, is going to be minus. This is a plus, is going to be minus. That means this one is going to be 0. 13 minus 8. Okay, 13 minus 8 is going to be 5x to the power 3. Now, next step, I'm done from this one. I'm going to write down plus 40x squared. I'm going to keep going, do exactly the same thing. 5x cubed divided by x is going to be, you can do it on the side. You can say 5 x cubed divided by x cubed, or by x, it's going to be 5x squared. So I'm going to write down here plus 5x squared. Now let's multiply. 5x squared times x is going to be 5x cubed. 5x squared times 8 is going to be plus 40x squared. Change the sign. This is positive, is going to be negative. I think we have something wrong with the sign. Now change the sign. This is negative. Positive is going to be negative. Positive is going to be negative. In this case, we're going to cancel both. This one is going to cancel, and this one also is going to cancel. We have to bring down minus x. So minus x minus 8. Let's write down just minus x. So negative x divided by x, we can't because we have 8 here. So I'm going to say minus 8. Negative x divided by x is going to be minus 1. Now negative 1 times x is going to be negative x. Negative 1 times 8 is going to be negative 8. Change the sign, minus to plus, minus to plus. This is going to be 0, and this one is going to be 0. That means the remainder is 0. This is r of x. So in this case, there is no remainder. So the division of f of x divided by d of x is going to be the quotient q of x plus the remainder over the divisor. That means it's going to be the quotient is x cubed plus 5x squared minus 1 plus 0, the remainder, and the divisor is x plus 8. Now 0 divided by any number is going to be 0. That means in this case, f of x divided by d of x is going to be, this is 0, the remainder, so we just have to write down x cubed plus 5x squared minus 1. That's it for this example. So we got the right answer. Write down these. Synthetic division is really important because we're going to use this method a lot, even in section 3.4, 3.5, when we need to factor polynomial from degree 3 or up. 3, 4, 5, 6, 7, and keep going. You can use exactly the same method. So to divide that, you see we have the factor x minus k. Always we're going to write down k on the side. And we're going to write down here the coefficient a, b. There's no b here. So be careful always, because the b with the x squared is missing. So 0x squared. So we're going to say this is b, x squared is the missing term. That means always we have to write down the missing term and write down the polynomial from the highest exponents to the lowest exponents. Here's the coefficients a, b, c, and d. B is the missing coefficient. Then the next step, you're going to write down the first coefficient. Then you're going to start multiplying k times a, ak. Then you're going to write down, add these two results, and then you're going to multiply k times the result here. It's going to be here. You're going to add these two results. It's going to be here. Then you can multiply k by the result to write down here, and keep going until you get the remainder. Now this is the remainder. This is going to be the constant, the number here. The number here is going to be the coefficient of x. The number here is going to be the coefficient of x squared. And that's how you're going to factor any polynomial with degree 3, 4, 5, 6 by using this method. So this method is really important, more than the long division. And by doing examples, it's going to be easier. So let's focus on example 10. And they ask you to factor this polynomial, 3x cubed minus 30x squared plus 32x minus 45 divided by x minus 9. Let's check how we're going to use the center of division on this method to find the solution for this example. I'm going to look. Do I have missing term? X cubed, 2, 1, and 0. This is x minus k. That's mean what I'm going to do, I'm going to write down the coefficient. There is no missing term. I'm going to write down k here, x minus k, x minus 9. So k is going to be equal 9. So I'm going to write down 9 here. Then I'm going to write down the coefficient, 3, negative 30, and 32, and here is negative 45. I don't have any missing term, so that's what I'm going to do here. So now next step, what I'm going to do, I'm going to write down the 3. Then multiply 9 times 3 is going to be 36. Let's write down this in another color so you can know. Here is the 3. 9 times 3 is going to be 27. Now add these together. Negative 3 plus 27 is going to be negative 3. Again, 9 times negative 3 is going to be negative 27. Let's add these together. 32 minus 27 is going to be 5. Now multiply 9 times 5 is going to be 45. Add these together is going to be 0. That's mean R of x is 0. This is the remainder. R of x is 0. And this is the constant. This is the coefficient of x. This is the coefficient of x squared. That's mean what they ask us here. Just write down the result. Okay. So let's do the steps again. Write down this number here. Then you're going to multiply 9 times 3 is going to be 27. Then 27, you can add these together, is going to be negative 3. Then you're going to multiply 9 times negative 3 is going to be negative 27. Add these together is going to be 5. 9 times 5 is going to be 45. Add these together is going to be 0. That's mean the result here from the division between this one and this one, f of x, which is divided by d of x, is going to be equal. The first number is going to be 3x squared. This one is going to be minus 3x. This is a constant, and the remainder is 0. I don't have to write it down. In this case, you see, this is a factor of this polynomial. That means if we need to factor this one, we're going to say f of x equal 3x cubed minus 30x squared plus 32x minus 45. This is extra notes. If I need to factor this one, I'm going to say f of x equal x minus 9, and the rest is going to be 3x squared minus 3x plus 5. So if you multiply x minus 9 times Well, I got from here the quotient, because this is q of x. You're going to go back to the f of x. So now this one is easier to factor because it's a quadratic. So that's why we're going to use this method a lot to factor any polynomial with degree 3, 4, 5, 6. Because if you multiply the factor x minus 9 times here, you're going to go back to the original polynomial, which is f of x. So this is the method how to factor polynomial. But now in this example, we just have to write down the result what we got here, which is 3x squared. Sorry, we got the 3x cubed, 3x cubed, and minus, 3x squared, 3x squared, and minus 3x plus 5. We're going to do the same thing with the next example, example 11. So let's work on this example. The first thing I'm going to do, I'm going to check if I have missing variable here, cube 2, 1, 0. That means there is no missing term here. So here is x minus k. Be careful here. That means k is going to be equal -4. So I'm going to write down here -4, not 4. This is also really important. If you change the number, everything is going to be wrong. I'm going to write down the coefficients here. So 6, 33, and 30 here, and -24. So next step, what I'm going to do, I'm going to write down the 6, -4 times 6. Now it's the time to multiply. -4 times 6 is -24. Now, 33 minus 24 is going to be 9. Now I'm going to multiply again. -4 times 9 is going to be -36. Add these together, so it's going to be -6. -4 times -6 is going to be 24. Add these together is going to be 0. So the remainder in this example also is 0. Be careful, because sometimes the remainder is not 0. But in this example, it's also the remainder is 0. This is the constant. I'm going to keep in my mind, this is the first number here is the constant. And this is for x, and this one for x squared. That means f to the x divided by d of x is going to be equal. This is the coefficient, so it's going to be 6x squared plus 9x minus 6, and this is 0. That's it. So if you want to factor this polynomial, is going to be this one times this one. And this is easier to factor because it's a quadratic. So let's type this one here. So it's going to be 6x squared, 6x squared plus 9x minus 6. That's it for this example. We're going to do exactly the same thing. So you will see. So don't worry if you missed any of these examples. 12. So if you look at this example, always before, check if you're missing variable and the polynomial is written from the highest exponent to the lowest one. If you look here, x squared here and x here. So if you did the scientific division, your result is going to be wrong. So you have to write down this first, then the 8. So this one is going to be 5x cubed plus 25x squared minus 8x minus 40 and divide by x plus 5. Then this is here x plus 5, that means x minus k. So in this case, k is going to be equal negative 5. That means I'm going to write down here negative 5, and then I'm going to start write down the coefficients. The first one is 5. This is a 25, and here is negative 8 and negative 40. I'm going to write down the first number, which is 5. Now, negative 5 times 5 is going to be negative 25. Add these together is going to be 0. Negative 5 times 0 is going to be 0. Add these together is going to be negative 8. Negative 5 times negative 8 is going to be 40. Positive 40. Add these together is going to be 0. Now, the same thing, our remainder is 0. This is the constant. And this is for x, and this is for x squared. That's mean, you see, this is for the x. That's mean the coefficient x, 0x. So there is no term with the x. So the division of f of x divided by d of x is going to be 5x squared minus 8. Because the remainder is 0, and the coefficient with the x is 0, so that's it. So we're just going to type 5x squared 5x squared minus 8. That's it for this example. For the example 13. So let's check this example 13. First of all, we're going to check the exponents. X cubed, there is no x squared. So I'm going to say this is negative x cubed plus 0x squared. If you're not doing this step, everything is going to be wrong. So we have to add the missing term. Plus 123x minus 252 equal, divide by x plus 12. Then now I'm going here to check x minus k. That's mean k is negative 12. So in this case, we're going to write down negative 12. Write down the coefficient. Here's negative 1, 0, 123, and negative 252. Now let's check how we're going to use the scientific division to find. So the first one is negative 1. Always I'm going to write down this number. Then negative 12 times negative 1 is going to be 12. 0 plus 12 is going to be 12. Let's multiply again. Negative 12 times 12 is going to be negative 1 4. Now add these together. It's going to be negative 21. So here is negative 21. Now let's multiply 12, negative 12 times negative 12 times negative 21 is going to be 252. It's going to be positive because negative times negative is going to be positive. Add these together is going to be 0. So our remainder is 0. This is the constant. This is for the x, and this is for the x squared. That's mean f of x divided by d of x is going to be negative x squared plus 12x minus 21. That's it for this one. So we're going to say here it's negative x squared plus 12x minus 21. Let's go to the next example. So before we move into the next example, just to give you a note here, that means if you multiply, or if you want to factor f of x, which is negative x cubed plus 123x minus 252, if you want to factor this one, f of x is going to be x plus 12 here times q of x, which is negative x squared plus 12x minus 21. So f of x is going to be d of x times q of x as a factor. D of x, which is this one, that divides times the q of x. Here is a q of x. So this one is a q of x. If you multiply these, you're going to go back here to the f of x. So the first thing before I start dividing these two polynomials using the scientific division, let's check here. X cubed squared, there's no other term with the x. So we have to write down the missing term. So it's going to be 3x cubed minus 21x squared plus 0x minus 108, and everything is divided by x minus 6. K equal x minus k. That means k equals 6. K equals 6. Then what I'm going to do, k equals 6. Write down the coefficient here, 4 and negative 21 and 0 and negative 108. Then I'm going to write down the first number, 4. 6 times 4 is going to be 24. Then next step, add these together is going to be 3. 6 times 3 is going to be 18. Add these together is going to be just 18. Now 6 times 18. 6 times 18 is going to be 108. Add these together is going to be 0. So the remainder is 0. This is the constant. And this is for the x. And this is for the x squared. That's mean f of x divided by d of x is going to be 4x squared plus 3x plus 18. That's it. So we're going to write down here 4x squared plus 18 plus 3x plus 18. That's it for this example. We're going to do the same thing with example 15. Example 15. We have x cubed minus 4x squared plus 6. And everything is divided by x minus 5. The missing term here is the x. So I'm going to write down this again is x cubed minus 4x squared plus 0x plus 6. And everything is divided by x minus 5. So here is x minus k. In this case, k equal 5. That's mean here is k equal 5. I'm going to write down the coefficients here, 1, -4, 0, and 6. Then write down the 1. 5 times 1 is going to be 5. Add these together, so it's going to be 1. 5 times 1 is going to be 5. 5. 1. 5 times 1 is going to be 5. Add these together is going to be 5. Now 5 times 5 is going to be 25. Add these together is going to be 31. Check the remainder. The remainder is not 0. So that means I'm going to say f of x divided by d of x is going to be equal. This is the constant. This is the x, and this is the x squared. That means it's going to be x squared, the quotient x squared plus x plus the constant 5 plus the remainder, which is 31, divided by the divisor, which is x minus 5. So this one is totally different than the previous examples because the remainder is not 0. So we have to write down the remainder divided by the divisor. X minus 5, yes. So here is going to be x squared plus x plus 5 plus fraction, which is 31, divided by x minus 5.